Hi there. Thought I'd make a quick video showing how to set up your Eachine Racer 250 mini quad. I'll go over adding a receiver with or without PPM, configuring the CC3D flight control board, controlling the lights from your transmitter, required video gear, video transmitter, channel selection, on-screen display, and antenna. Optional removal of the rear light so that you can fly with bigger batteries. And finish it off with a little bit of test footage from the GoPro. So an important thing to note is before ever plugging in the quad, make sure you've got the antenna attached. When you plug this in, your video transmitter is going to be on, and if you don't have an antenna on, from what I understand, you can fry your transmitter. The first thing you want to do is get your receiver, and it doesn't matter if you've bound it to your transmitter yet or not, but you want to decide if you're able to, or if you want to, use PPM. And PPM means you have all your signals on one channel. The D8R2 Plus isn't capable of it, but this one's been flashed with the X8R or something like that, so it's PPM capable, which means from the wiring harness from the flight control board, I don't need any of these ones. I've already removed these from the plug, and I'll show you how to do that now. It's pretty fidgety. You can just get the tip of your screwdriver on the one edge, going from side to side, and pulling on the cable helps a little bit. Should be able to get it free without damaging the wires. Now to remove the plugs, it's fairly easy. Just flip it on the side where you can see some metal. Just get your X-Acto knife tip in there, give it a little bend up, and with your third hand or some fingers, tug on the wire gently. You'll be able to pull them all out. All you need is one servo's worth of wires. So the black and the red power the receiver, and the white is our incoming signal line. And if you're not using PPM, obviously you don't need to do this step. You just leave all those wires in. Now ready to mount the receiver. There's a very small space for it right there in front of the battery and between the video transmitter on the top and the control board below. They've even included a piece of double-sided tape for you to stick it to. This, even without the case, doesn't quite fit in there. So I'm going to put mine on the top here, just like that. There's plenty of holes for zip ties to go around, or you can use Velcro or double-sided tape, whatever your preference is. This lead is not tremendously long, so depending on where your antennas come out, it might be a bit of a tricky routing for you. Ideally, I'd put it like this, so my antennas could just run out the booms here. But with this way, the plugs are on the back, so this lead won't reach. So, because of the length of that lead, I'm going to mount it this way. So decide your receiver mounting location and feed the PPM input wherever it takes up the most slack. I think I'm going to run it underneath this camera platform here, so I need it to reach around here. There we go. A couple zip ties and the receiver's installed. So if you're not using PPM, the order of the channels is following the red, black, and white, the first ones that are on the left of the plug. That's channel 1, including the power supply, red and black. And it just follows numerically from there. Channel 2 is the next one over, 3, 4, 5, 6. And you just plug each of those into your receiver, the order they come out of the flight control board. So at this point, it's time to configure the control board. And you do that with some software. So go to openpilot.org/download to get the GUI. So it says at this time, the latest release, CC3D is not supported. So got to use a previous one. So this 15.02.02 release does support CC3D. So download that for whatever platform you're on. Now you have to plug in your mini B USB cable, which is easier said than done. So pretty much have to just do it by eye, get it started, and then use some kind of poking device to get it all the way in there. So with it connected, open the OpenPilot Ground Control Station app. It should connect automatically. We'll go to the flight data screen, and if you move your quad around, it should show up as moving the right way. So just verify that it does. So on the configuration screen, if you're using PPM, you'll need to configure what the receiver port should expect. PPM plus no one-shot is what I'm supplying. If you're using all the receiver cables, what you'd want is PWM. And hit save. Next, go to the vehicle, make sure it's a Quad X. And this diagram here shows you the rotation, so that both the front propellers spin in towards the front and the back propellers spin in towards the back. So assuming you've connected your receiver, you want to make sure that all your channels are set up the right way. The default on my transmitter is RETA channel order, which is rudder, elevator, throttle, and aileron, and then have the flight mode on a 3-position switch coming through on channel 5. The transmitter setup wizard does a pretty good job of setting these for you, and you can see the flight mode switch has 1, 2, 3. By default it'll have 1, 2, so if you're using a 2-position switch you'll only have 2 flight modes to be able to choose from. If you have a 3-position switch, 3 flight modes, and so on. The number of flight modes is configured in the upper right hand corner. Stabilized 1, 2, and 3 are my flight modes, and here are the descriptions of those flight modes. So you can set these to whatever you want, and I've just used some defaults here. So roll and pitch are in horizon mode or auto level mode in the first 2 flight modes, and the 3rd flight mode is called rate mode, also known as acro. Alright, so the arming settings, usually you'll use yaw right and save. While you have the RC input screen up, you should be able to move your sticks around. That is, if you have your quad powered, the USB won't power your receiver. At this point my receiver is powered up, and you can see it's a huge lag, I don't know why, but you should be able to move your sticks around and see these values moving. Go to the output screen, and obviously your props are off at this point. Spin that up and confirm that it's spinning the right direction. So northeast, front right motor, also spinning this way and towards the front. Southeast motor is number 3. Make sure that's spinning in towards the back. And southwest motor, make sure that's also spinning towards the back. Back on flight data, you should be able to check if your arming and disarming is working as expected. So in case you're wondering what this cable is for, it's for the lights. Control the lights from the 6th channel on your receiver. If you do have PPM enabled, then the rest of your pins should be open for this. If you are using PWM and you plugged your 6th channel into the CC3D board, you'll have to unplug it so you can use it for the lights, and you won't be able to use it for whatever CC3D functionality. But the lights are so bright, you'll either want to just leave them off all the time or hook this up to control them. This is just a white and black wire. Plugs into the board right in there, and this end goes into your receiver. White signal, black is ground. The ground's not actually required since it's shared from the PWM or the PPM cable going to the light control board. So I'm going to take that off the same way I took off the wires from the CC3D connector. With the black wire removed, left with just the white wire. Now we're ready to put this in. You can just kind of start it. And once you get it in there, you should be able to get your pinky finger to push it down. And then this goes into the signal pin of channel 6. Actually, I'm going to mount this underneath my camera plate. Now, lights are controllable from the switch. So, it should be noted, kind of a strange behavior. It looks for a signal on to turn it on or to turn it off, meaning if you put it on a momentary switch like this, it'll return to home on its own. If I put it on this switch, I'd have to go that to turn it on, and then that again to turn it off. Okay, now for the video equipment that you'll need. It comes with a transmitter antenna, which is cool. It's a circular polarized antenna. I had to hold it up to the light though to determine that it's a right-hand circular polarized antenna. The thing about cloverleaf antennas is they're polarized either left or right, and the one that I have on my receiver is left-hand polarized. so I needed to switch it out for my other left-hand polarized antenna. Next, obviously, is the video receiver. This is a cheap RC305 8-channel 5.8 gigahertz receiver. The 8 channels that this has are all covered by the 32 that this has. You'll need some sort of viewing device. These are cheap $90 eBay video goggles. You'll need some wires to connect up the power to the video receiver and the power to your viewing device from your battery. You're probably going to use a 3-cell to power it. Assuming you already have all that stuff, we'll get on to setting up the video transmitter. An important thing to note is this camera does appear to be a PAL format camera, so your viewing device needs to be capable of viewing a PAL signal. These cheapy eBay goggles thankfully are. I might have gotten lucky there, or maybe they're all like that, I'm not sure. So there's two approaches you can take. You can try and tune your receiver to what this might default to. I don't know if it starts at A1 from the factory, but there's no way to know what channel you're broadcasting on until you receive it, and then you can see it on the OSD. So I use 5885 on my receiver, so that's what I'm going to try to get on the transmitter. I wasn't sure what channels the video transmitter broadcasted on, but thankfully it's the same as this other Eachine video transmitter, 600 milliwatt one, and the frequency chart by process of elimination and tuning mine have pretty much confirmed this is the correct one. So I transferred that to a Google Doc here. I'll share the link. So the way to change channels is this little red button here. Zoom in on that. The little red button under the camera platform is a 2-function button. A short press moves the OSD by a very small amount, and the long press changes the channel. It's not auto search, just increments through A 1 to 8, B 1 to 8, C 1 to 8, so on. So basically you just want a long press over and over. And I think long press is a good second and a half until you get something on your capture device. So D8 is coming through. And if we look at D8, it's 5880. And the channel on my receiver is 5885. So you can see why that's coming in. But don't be fooled. You want to get it exact, and this one is C5 that I'm looking for. So being on D8, I have a fair number of clicks to get there. So there we go, back around to C5. So you can see the on-screen display here. It's giving you the time since you plugged it in, voltage, and the channel. So a short press moves that down a line or two at a time, up to 10 times, and then it disappears, and then it starts again at the top. So the Eachine Racer 250 comes with this 1500 milliamp 3-cell, and as you can see, it fits in just fine over the tail light. I happen to have some of these 2200 60Cs lying around, and they're a centimeter and a bit longer, and probably half a centimeter or more thicker. And unfortunately, they're too big to fit in because of the tail light. First, you have the backing board, which is fiberglass and has a positive terminal soldered to it on the back. The negative terminal is on the front, underneath the actual metal bezel and LED strip. You can carefully pop that off. It's held on with double-sided tape. The metal bezel can come off beforehand. It's got 4 metal tabs and it's very soft metal. So I pried this off previously using a screwdriver. And the LED strip is connected to the circuit board on the left side, and it has 2 board resistors that stick better to the LED strip than they do to the board. So it can be destructive. this isn't that big a deal. I can just scratch off the ends and solder them back on with wire. Now that the LED strip is off, you can get at this front terminal. I just scraped away some of the foam tape and desoldered using a desoldering bulb. Using a screwdriver, pry off the backing board. I'm going to put a JST connector on there for any lighting solution. Of course, best of all, fit in a 2200, no problem. Putting on the props is fairly straightforward. You'll notice when you're taking off the nuts that two of the motors have their threads the normal way, and the other two motors have reversed threads. This is because they're self-tightening. This one and this one are clockwise, and this one and this one are counterclockwise. So it comes with two sets of props, one white, one black. The first time I put these on, I actually had to screw them on and then screw the nut on. Now the only thing left to do is attach a camera to the camera platform using a little dollar store Velcro strap and go flying. So I'm not a great FPV pilot, I'm just beginning, but I wanted to comment on the camera quality. This is GoPro footage here, and at certain times of day when the light is low and you're heading into shadows, like right here, visibility can get pretty impaired. So I just wanted to say the camera that comes with the Eachine Racer did pretty well in that scenario. To compare it with, I have a 700 line 1/3 inch CCD Sony camera, and it does comparably with that. I find the colors pretty saturated on this camera, but other than that, it performed pretty well. You can see it wobbling around a fair bit here. It was a bit of a breezy morning, but not too bad. So this I don't know if it's a combination of the wind and the flexible props, but leads me to believe there's some tuning to be done. If not, then stiffer props would probably help quite a bit. So flight time on this wasn't fantastic with the GoPro on it and the stock 1500 milliamp battery. I got less than 5 minutes flight time. So I'm really hoping the 2200s make an improvement on that above and beyond their extra weight. And of course, in any racing situation and probably normal flight, I'm not going to be carrying the GoPro. So hopefully things improve as far as flight time goes.